Hello and welcome to part 2 of our Telekinesis tutorial. This video will go through the different ways of throwing our grabbed object, as well as setting up a damage response for enemy character when hit to go into a ragdoll state. Now here we are where we left off last time off the first video. I've just cleaned up the blueprint a bit. I've added one extra function here. I left this off as a note in the previous video for angular dampening. I have added this node right after we set the linear dampening and also set it to 25 off of our move object to hand event. And when we drop the object right after we had the linear dampening set back to 0.01, I did the same for angular dampening. And of course, don't forget to do that in the object to set it back to default. But other than that, nothing else has changed. Now, this tutorial is going to go through 3 different options for how to throw our projectiles, and this will also bleed into our third part of working with our character blueprint. If you've looked up any tutorials on how to throw objects, you most likely have seen add impulse before. All it does is apply a force to a target in a vector. So if we add a forward vector, whatever object we have set as the target is just going to fly in that direction. It requires the use of simulated physics, so we can't turn that off. Luckily, we've already set up this project to work with simulated physics from the jump, so that should be no issue at all. The next is adding a projectile component, which you can either do so in the object blueprint, or we can set it in the third-person character, but we're going to set it up in the object and use the blueprint interface to pass the information to our object from our character. And we can go through setting up all of the options for a projectile, including homing, and a boolean for whether or not we want it to home to a target. And then finally, we'll be working with Lerp vector as well to get it from its position in the primed location to our target, as well as have a distance formula so then it travels at a uniform pace. Because if we just plug in a Lerp vector, the speed is going to be different depending on the distance because it cares mostly about the time it takes to get to its location rather than covering a uniform time. So we're going to start off with getting a keyboard event. And we'll bind it to left mouse button. And we're going to start off doing basically the same thing as dropped object. So we're going to copy all the nodes here. Do not copy drop object because what we do is going to change depending on what our type is. Since we'll be using our impulse method first, we need to leave simulate physics and set gravity enabled as checked. When we move on to the projectile component, we'll need to toggle that because simulate physics and projectile movement components are incompatible. And if we're lerping, we may want to turn off the gravity. So we'll be editing this row as we go on for each method. So as a shorthand, I'm going to add a custom event. I'm just going to call this pre-throw. This is everything we want to do before we throw our object. We'll set this up using the impulse of our spear trace, so we can get the end location of our follow camera. And our add impulse target is going to be our throwable object. We'll automatically assign the cube. And when we add an impulse like this, we need to really scale this up. So if we set it to something like 60,000, when we pick up an item and we click, it throws it in that direction that the camera is facing. Starts to get a good amount of force behind it if we increase that number to 120,000. Alternatively, if you don't really care about the mass of the object, we can check the velocity change. And we can cut off about 2 zeros from this. It'll have a very similar effect. So one thing that we're going to do is take this grabbed object and reset priming. And we're going to be setting that after we throw. And if we click left mouse button, but we don't have a throwable object, we're also going to be running into an error. So we're going to check to see if our object is primed, because in that case, we've already grabbed it. We can also check to see if the hold timer is currently running. And whichever one you set will determine when you can throw the object. If you can only throw it when it's primed, it'll only be thrown when the player grabs the object. If we just have it running when the timer is active, then it can be thrown as soon as it's picked up, even if it's in transit. And we can have a bit of a cooldown. So we'll get a delay of 1 second. So after we throw our object, we're not able to grab it again. And if you don't want to keep the overlay on the object that we've thrown, you can make a custom event. We'll just call it deselect actor. And we'll set the change material highlight to false. And call it right before the delay. So now when we throw this, it no longer has the overlay, and we're not able to grab another object for 1 second. So that's pretty much the setup to the add impulse. Now we're going to go into BP enemy, and we're going to create a event to handle going into ragdoll when there's any damage that's taken. And we're going to assign damage to our object when it's thrown at our actor. So we'll get an event begin play. We're going to make use of an event dispatcher that's built in. You can bind event to untake any damage. Drag off the event, and we can just create the event, and we can make a matching event if it doesn't populate an event for you, and we'll just call it damage actor. So we'll start off with 2 simple functions here. We're going to set collision enabled for the capsule component. And we're going to want to set this to query only. And then for the mesh, we'll set all bodies simulate physics. And check that to be true. We'll be using this node a bit more in the 3rd video, so I just want to use it now. And so we can go back to our BP object, and we're going to make an event to handle damage. And for damage, it's fairly simple. So we already have our box overlap, and we have to check to see if this is highlighted, just so then we have this be interrupted when it is our selected object and held in our hand. We don't necessarily want to worry about this right now, but we still want to use it. Instead, what we'll do is just right click and get apply damage. And the other actor is going to be the damaged actor. And we'll just send 1 point of base damage. Okay, so now if we test this out, that shouldn't happen. On BP enemy. Okay, so for collision enabled, we had it set to query only. So we just want to set to be collision enabled. There we go. And that's the desired effect. So naturally in this state, if this box just overlaps with the actor, then it's going to deal damage. So if you have an enemy that just walks into a static object, that box still exists. So they're just going to crumple over. So we need to have some way of stopping this. And we could reuse highlight if you didn't want to go through the deselect actor. As while we have the object active and flying, that would suffice, but we're going to get a new interface function. We're just going to call it damageable. And we'll just have a single boolean as an input. And we'll just call it damageable. So back in our third person character, after we throw our object with an impulse, we're dragging a throwable object. And we'll call damageable and set it to be true. And now back in our object, get a branch. I'll just have our interface damageable, double click, and promote this to a variable. We just say can damage. So now if we take the object and we hover it by our actor, it's not going to deal damage until we throw it, and then it can. Unfortunately, this is still going to deal damage in its static location. So the third person character, after our second delay, we can uncheck it here. We can also, after it takes the damage, we'll set can damage to be false. So it can only apply damage once. We'll need to take our can damage on false and route it back over to our branch so we can still interrupt. There are a few ways to handle damage, but since this isn't a tutorial about that, we're going to leave it there. So that will set it to damage the actor and send it to be in a ragdoll state. And that is everything that we want to do with our add impulse. So the next method is to add a projectile component. We could do this here, or we could do this in our object, and we can also do this in our enemy. The benefits of doing it in our third-person character blueprint is because we may not want to have this projectile movement component information in every object. However, unless you have literally thousands of objects, it's not going to affect performance. We'll change how our damage works with our projectile component, as we'll have more options than what Impulse offers. We're going to move the damage component to BP object. First, we can start with this damageable and delete it. And back in BP object, after we set event damageable true, we can effectively get the same results if we put a delay here and set can damage to be false to give ourselves a window. And to set up our projectile movement component, we're going to set up an event inside our BPI throwable interface. So then we can plug this information in and assign it to an actor that has the interface. That way we can set the values that we want as we go. So we'll add a new function and we'll call it throw actor as projectile. And the inputs are going to be whatever we want to set for the projectile component information. So we will have an initial speed of type float, a max speed, we'll have a velocity, type vector, and we'll have a homing check of Boolean. Now, the only thing we can't do with this interface is if we wanted to set this up as a function, when we have a target, the homing target needs to be a weak scene component, which can't work in functions. So then we'll just pass that information, pass the function into our blueprint. You'll see what I'm talking about. We want to get a reference to our target actor that we want to hit. And we can just get actor. In our VP object, we can double click on our throw actor as projectile. And we could set the information here for projectile movement component. So I'm just going to add this to our object and make a new function. This function is just going to be called projectile information or projectile info. And it's going to have the same inputs as we just set for our interface. However, we don't need to add the actor reference. We're going to be setting that after the fact. And one output we're going to add is just going to be called isHoming. Drag in our projectile movement, and we'll set each of the variables. And once that's done, we'll go back to the event graph and drag in our function and connect the pins. Then for our actor, we need to get component by class. And switch the class to a scene. Because if this is homing, we'll get a branch. And drag in our projectile movement. And we'll set the homing target. So the homing target needs to be a scene, not the actual actor. Then we'll get the homing acceleration magnitude. And set that to be 3000. The acceleration magnitude is how strong the force of pull is to our target actor. So the higher the number, the stronger the pull. In our projectile movement, we're just going to set this to be inactive when we first spawn it. So auto activate, uncheck that. And we need to set updated component. And assign the cube to the new updated component. Essentially what this allows us to do is after we throw the projectile and it lands, it's still going to have the projectile component. Or if you have it so then you can re-grab it in the air, if you try to launch it again without the update, it's not going to project. So this ensures us that we can relaunch the projectile if that's something that you want to do. And then finally, after this point, we can activate it. And if this is not homing, then we don't have to worry about any of the homing configurations. And we may want to have a variable so then we can set this to be active. And if a projectile is active, we'll check the collision box to be able to deal damage. And if it's not active, then it's not going to deal damage. So we'll just call active and set it to be true here. Now, off of our damage, we don't need to worry about the can damage, since that was entirely for the impulse damage. I'm going to take this and collapse it to a node. And just disconnect the pins. Because now we can get a new branch, check to see if our projectile is active. Then we'll apply damage. To our other actor. Then we'll dip back into our third person character, and we need to get a actor to target. We don't want to set the variable of throwable enemy, because when we start using that, we don't want to throw it directly into itself. So we'll get actor of class. And set it to be BP enemy. We'll put that on event begin play. And promote it to a variable. And we'll just call it enemy target. Now after our pre-throw, we're going to call our interface of throw actor as projectile. We'll remove our impulse data. We'll get our enemy target to be our actor. We'll set homing to be true. We'll fiddle with the velocity, and the initial speed we'll say is 1400, and the max speed is 2000. But before we throw our object, we need to fiddle with the physics. When we're throwing from the position of being primed, we want to enable gravity again, and we need to turn off simulate physics, so we can just copy these nodes. And then we just need to switch them around to make sure that gravity is enabled. Simulate physics is off. We could ignore the damageable. So back in BP object, we can collapse the apply damage to a node. And we'll just call it projectile damage. Take our cube, and we'll set it back to simulate physics. And then after it hits, we can also take our projectile movement component and then deactivate it. And now that we have an activation and deactivation, we're going to just remove the activate boolean, but we're going to keep the variable so we can use it during our lerp. Instead of checking to see if this is active, look at the projectile movement and get is active in the list. So this will work. We throw it at our actor, the ragdoll, Our object takes the velocity, it bounces around. That's good, except if we were to just hit the floor, it doesn't do that because our collision to the floor is entirely different. And so now if we wanted to, go up and hit it while it's in its rest state, we're overlapping with the box, so we're still changing the simulation settings, but it still thinks that it's an object in motion, so we're not setting the physics and gravity back. One way that we can get around that is for our cube. If we go all the way to the bottom of the list for on component hit, we'll create a new event. Inside our projectile damage, we'll copy both the simulate physics and deactivate and leave them connected. And then on our component hit cube, actually just add this boolean to check to see if our projectile movement is active, so then we're not just setting simulate physics to be true every time this cube has a hit event, which is going to happen every time it hits an object. And if we hit another object while this is active, it will do the same thing if we're just hitting a floor or a wall. We don't have to worry about setting simulating physics if we don't want to while we're holding it in our primed position. So now if we throw this, we get a proper bounce. And as soon as it hits the ground, it deactivates the projectile, so it's no longer going to be homing. Okay, so now we'll move on to our last option, which is using Lerp. Specifically Lerp vector. And setting the actor's location. This setup is going to be very similar to our move object to hand, where we run it off of a timer and then clear the handle when we have a hit. So off of our set simulate physics, we will set timer by event. We have a new custom event. We'll call it move to target. We're going to drag in our throwable object and get that actor location. Then we'll get our enemy target and get its actor location. And the alpha is going to require a little bit of calculation, because if we start it again, if we just have an alpha of whatever it is, if we are standing 500 units away or we're standing 1,000 units away, it's going to lerp the vector in the same amount of time, so the speed is going to be different. So to calculate the alpha, we're going to get the world delta seconds. And divide it. And we're going to copy the throwable object and enemy target. And we're going to get distance too. Then we just need to divide this distance by the total time we want it to take. But this is going to be dependent on our timer speed. So we're going to set this to be 2000 at first. And off of our timer, we'll set it to loop at 0.01 seconds. Over here, we're going to promote the return value to a variable, and we're going to call it object throw timer. And we'll want to have sweep checked as well. So we'll break the out hit of the sweep result. We just need a reference to the hit actor. Then we can collapse it to save some space. and get a branch. And we'll say if we have a blocking hit, and if the hit actor does not equal our player character, because we don't want to accidentally hit ourselves. So we'll get player character. Because if we don't do a check for our character, Lerp has the highest chance of all three of these to interact with our character mesh. We could set the vector for our impulse to just be forward. We could do the same thing for the projectile, having an initial velocity of just our actor's forward vector. But with Lerp, we can't really do that. We're just starting off at the actor's location of the object, so it could go right through our character's mesh, depending on where you put the scene component. So we just need to really worry about this check. But if the hit actor is not the player character and it is a blocking hit, then we're going to end the object throw timer, because we've either hit the target we intend to hit, or we've hit an obstacle in the way, in which case our path is disrupted. So we'll clear and invalidate timer by handle, drag in our object throw timer. We'll set prime to be false. We can get rid of the delay that we had before. Optionally, we can keep the deselect actor. And we'll want to set gravity and simulated physics. So we could just simulate physics. So we set simulate physics to be true. And our actor location, oops, it needs to be the throwable actor. So if we test this out, grab an object, throw it. If we get further away with our distance, it's traveling at the same speed. If we increase this, then it increases the rate in which we throw this. I'm going to keep it at 2000 still, just because I think that's a good speed. Now, when this object collides with our actor, we need to go into BP object, and we need to make sure that this hit is capable of simulating physics on our actor. So we can get it by the on component hit for the cube as well. We're going to get a branch and check to see if it is active. As I said, we'll be using this for the Lerp. So we'll be setting that in our third person character when we start the timer. So when we hit it, we can set active to be false. And then we can apply damage. Back in our third person character. Right after our object throw timer, we can copy our throwable object get. Let's set active. When we have a block hit that is the player character, we don't have anything to really handle that. Unless you wanted to have something to transfer this object from one scene to another scene around your character, or just change the scene component position, maybe above and behind your character. What we're going to do is temporarily bypass sweep. So route this to a variable. And off of this branch, we only want to do this if our player character is the swept actor. So we'll just get a not boolean. So essentially off of true is that we swept and hit our player character. We're going to take our sweep, set it to be false, get a short delay, and set it to be true again. And we have to check to see if this actor is in fact a player character, because if we do this when we hit a wall, we're going to turn sweep off and the object's going to go through the wall. And this is still going to generate a hit in our BP object. So we just need to go and check to see if this hit cube is hitting our player character as well. So we'll see if the other actor is not our player character. And if it is active, then we'll turn active off and apply damage. Then when we hit, we want to simulate physics again, which means we can remove it from the player character. And just in case of any delays with our timer, we'll check to see if the throwable object is valid before we try to move it. And if it's not, then we'll just end the timer. And if you find that the drag force of gravity is a bit too much for Lerp, we can uncheck enabled gravity and pre-throw. And then in our BP object, off of our component hit for the cube, after we set simulated physics to be true, we'll re-enable gravity. And now when we throw our object and it clips through our mesh, it'll go straight through to the enemy, just as if our character wasn't in the way. And again, if there's something in the way, like a wall or an obstacle, then we just simulate physics as normal. And last video, I had mentioned that there was a download from the Patreon for the overlay and a few other animations. That's still linked in the description if you want to use what I'll be using here. If you've already followed the first part of the tutorial, you probably already have it. So I'm just going to set this up in our character's anim graph. So we'll copy our owning actor, then we'll cast it to the third person character or whatever your character's name is. I'll put that up by the initialize animation and promote it to a variable. Then, like the character check, we'll convert it to a validated get. Get the object grab variable. And promote that to a variable in our animation blueprint. And just connect a pin to it. And the demo stuff is, again, all taken from Mixamo. It's the one-handed animations. We have a standing one-handed attack, an idle, and a forward run. So in the anim graph, we go back to our locomotion. We'll take our idle, and we'll drag in the hanging idle. And we'll blend poses by pool to switch between it, depending on what the value of our object grabbed is. If it's true, we'll be using the standing idle from the demo. Otherwise, if it's false, we'll be using the normal idle that comes with the project. Then with our walk run, we'll be doing the same thing. We'll be using the running forward with the true. All right, and then on the running forward, we just need to select loop animation. And I think we might need to do that on the idle as well. So now when we're walking and running, we'll change the animation so then our character matches holding this item. Same thing with the idle animation, and when we throw it, it's no longer true, so we don't have to worry about it. And for our attack, we'll just set up a montage in our third person character. after we click the left mouse button, I'm going to get play and a montage. I don't need to really worry about having notify us. We're just going to be playing this. And then we'll get a delay of 1 second to match up with the animation. And is the standing one hand. If you have an issue copying this in, like this, the animation sequence may be unbound. You just delete it. In the asset browser, just drag in the one-handed, and it will recreate our montage. Or you can just recreate the montage from the animation, up to you. So we grab an object, play the animation, and at the end of it, we throw it. So just a nice little aesthetic. So that's pretty much it for grabbing and throwing objects. I'll be splitting this into 3 separate project files for each projectile type. So if there's a method you like and you just want to see what it's like with the necessary components, check the description. It'll be on the Patreon for free. And while you're there, you may as well click on the like button. It's on the way to the description anyway. Big thank yous to Winterberry Shark, Francesco Poda, and K Panic for being pillars of the Patreon. And thank you to everyone else who's been supporting me there as well. The next part will cover how to handle throwing character models and allowing them to get back up. So subscribe so you won't miss that and future tutorials like this one. So thank you all for watching, and I hope you've been inspired.